Hola, buenos días o buenas noches, según corresponda. Yo soy Horacio Pérez y os doy la bienvenida al podcast Investigando la Investigación, el podcast donde hablaremos sobre temáticas muy relevantes dentro del mundo de la investigación, como en qué temas actuales y de impacto se está investigando en todo el mundo, cómo llevan a cabo su investigación los investigadores y cómo es su vida y día a día, qué les motiva a investigar y qué problemas se encuentran y resuelven para poder seguir adelante. Y además nos centraremos no solo en la investigación académica, sino también en la transferencia tecnológica y en cómo se realiza la investigación en las empresas.
Hola, muy buenos días. Hoy es jueves 24 de marzo de 2022. En el episodio de ayer os comenté sobre el software Aqueduct, desarrollado por el grupo de investigación de Artur Gora en la Universidad Politécnica de Gliwice, en Polonia, y cómo puede ser útil este software para encontrar hotspots en proteínas y también túneles o cavidades y localizaciones precisas de esas partes de las proteínas para poder proponer moléculas interesantes, tales como inhibidores, que puedan tener un efecto antagonista, agonista, etcétera, frente a esas proteínas. Comentamos sobre él. Luego también comentamos que ese software había participado en su desarrollo la doctoranda María Bzówka, que actualmente se encuentra realizando una estancia de investigación doctoral en nuestro grupo de investigación, grupo BioHPC, grupo de bioinformática estructural y computación de altas prestaciones, aquí en la Universidad Católica de UCAM, en Murcia, España. Y también os comenté que hoy jueves y mañana viernes tenéis en la Universidad de Murcia un simposio para estudiantes de doctorado y postdoctorales en temas relacionados con física y química, y donde tanto muchos miembros de nuestro grupo de investigación como María Bzówka van a presentar sus trabajos. Entonces os dije que si estáis en Murcia o os pilla cerca, os recomiendo de ir porque van a haber charlas muy interesantes. Os lo recomiendo muchísimo. Entonces, en el episodio de hoy lo que os voy a poner es, relacionado con este trabajo de Aqueduct y con María Bzówka, la entrevista que le hice en septiembre pasado sobre su trabajo, sobre donde cuenta algunos detalles más interesantes sobre Aqueduct, su opinión sobre la ciencia, la investigación, cómo lleva el trabajo, cómo lo hace, etcétera, etcétera. Pienso que es una entrevista muy, muy interesante. Y como os podéis imaginar, y si no lo digo yo, la entrevista es en inglés porque yo no sé polaco de momento y la vida ya no me da para aprender más idiomas, ¿vale? Entonces, a continuación viene la entrevista con María Bzówka. Espero que os resulte súper interesante y no vayáis, por favor, que aunque sea en inglés, es inglés técnico y seguro que pilláis algo, ¿vale? Entonces, gracias por estar ahí y os dejo con la entrevista. Muchas gracias. Today we have the pleasure to have here Maria Bzówka from Silesian Institute of Technology. Is that correct?
University of Technology, Silesian University of Technology.
Okay, thanks. And we really welcome you to this show, and thanks for giving us the opportunity to interview you in today's episode. Okay.
Thank you very much.
Welcome. So Maria comes from Poland, and he's doing at the moment one internship in our group, in BioSpecies group, and she is working on the development and application of computational methods for the simulation of biomolecular systems. Probably I did many things wrong, but please, Maria, can you briefly explain to us what you are doing, please?
Yes, sure. First of all, thank you for having me here. So yes, as Horacio mentioned, my name is Maria Bzówka. I am a PhD student. I just finished my second year PhD in Silesian University of Technology. So I am in the middle of my PhD program. And yes, mostly I am working with different biomolecules, enzymes. And mostly I am doing molecular dynamics simulation of these enzymes to investigate the behavior, the dynamics of such enzymes. And I am also working in the field of drug discovery or at least I really want to work in that field. Sure. And also in our group, tunneling group, we are developing some software for the investigation of the structure of biomolecular complexes from the point of view of intramolecular voids. So basically, we are investigating the dynamics of the structures with the use of small molecular probes, such water molecules.
Okay, very, very interesting. That's very good for an introduction. Great. Now, Maria, before we go into detail, can you tell us how did you get into this situation? I mean, what did you study? When did you realize that this area was interesting to you? And why did you start your PhD studies?
Yes, sure. So basically, I think that the first time when I realized that I want to do something in common with science was quite early, when I was in a primary school, on even some secondary school, because I was always interested in this life science subject like biology, chemistry, or physics. So I really wanted to do something in common within this area. Mm-hmm. And when I was in high school, it was time to decide what I want to study. So for a short time, I considered maybe medicine would be a good chance, and it covers all these areas. But then I thought maybe I could somehow link it with some technical stuff, and I decided to study biotechnology. So very broad discipline. You have many options because there are like different branches of biotechnology, like bioinformatics, some related with environmental engineering, but also with drug discovery. And this is something what I like the most. And I did my bachelor and master in biotechnology. And actually quite early, because after my first year of bachelor, I found this opportunity to do a kind of volunteering job in new research group at our university, tunneling group. And this is how all of this started. I joined to the research group, and very quickly I was able to participate in different research projects in the area of computational chemistry linked with molecular biology. And this is how it started. And I really enjoyed all this project. And we had many things to do, many different things to do within the group. And I stayed in the group, and I also decided to do a PhD there.
And it was totally clear for you that you wanted to do a PhD after this master experience and interaction with this group?
Yes, it was kind of clear for me that I want to stay in academia, at least for doing a PhD, because I don't know what will happen next. But I decided that I really like to solve some scientific problems and to struggle with some analysis and with some things. And I think, that doing a PhD is a good opportunity and a good chance to do that. Yeah.
Okay, so you like to struggle with problems, and what is at the moment there is kind of a scientific problem that you are working on now, but I guess there is something like a challenge. What is your most relevant challenge that you are facing at the moment in your project?
Okay, so right now in our project, in our group, we are dealing with several things at the same moment.
Okay.
So basically, because of the current situation with the pandemic, with the COVID-19 pandemic, we are also working with the main protease of the SARS-CoV-2 virus, because at the very beginning of the pandemic situation, we really wanted to join to this fight with the coronavirus.
Right.
So the one thing is that we are working on this enzyme. So we try to do some investigation using in silico methods, but also like to check our predictions experimentally. This is with the collaboration with our colleagues. So this is one part. And the second part, which is like the core of my PhD thesis, is that I want to investigate the role of the water molecules in biomolecular systems, different ones. So for example, we are studying the epoxide hydrolase family of enzymes. And I also study some transmembrane proteins, which are toll-like receptors. So they are like my two main objects of interest. And I want to study the role of the water molecules, their potential impact within the protein ligand and protein-protein interactions. So this is what I am doing right now.
Okay. You mentioned COVID, and you mentioned that when the pandemic, the lockdown started,
yes.
Then you work in some paper that I found then at the moment, which has a very interesting title. The title was something like the main protease is not druggable or something like that.
And it's challenging target,
right,
for drug discovery.
Right. So that is for me a very nice title because, people are kind of expecting at the moment some positive result.
Yes,
but
of course.
Then you read the title and you read, there will be difficulties with this virus we are starting to live with. Okay.
Yes, exactly.
So, what was the main conclusion from that study? That we can work designing drugs against this protease, or did you find anything else?
The main conclusion was that it will be, and it is extremely difficult to find the drug which targets the main protease. Why? It's because that we found out by using our in silico techniques and our studies that this enzyme, and particularly the binding cavity of this enzyme, which is of the main interest, where we want to place inhibitors, is of high flexibility and plasticity. And it will be very difficult for inhibitor to bind to this cavity. And what we also found was that this cavity, this binding cavity, is very prone to mutate. So even if we could have like the potential inhibitor, it may be not very efficient. Also, in the case of some possible mutation in this region, and because this enzyme requires to work as a dimer and requires to be a dimer for the activity of the enzyme, we also pointed out that maybe the better strategy would be to try to target the region which is important from the dimerization point of view. So instead of targeting the binding cavity itself, maybe it would be better to target the other part of the enzyme, which is also very important because of the mechanism of the action.
And did you find in your research any interesting compound that could target either the main binding site or one of these regions that are relevant for dimerization?
We have some hits. And actually, this is something what we are working in collaboration with several groups. So we obtained some hits, for instance, for the virtual screening. And also we had some hits from the groups which synthesize some compounds. But as for now, we are in this stage that we are testing this experimentally. And as for now, I cannot say that we have like very promising results because it is a very difficult enzyme to work with. So I can say that still we are at the very beginning of this path to found some interesting compound.
Okay. Well, I'm not going to ask you any additional details. I understand, but yeah, this is a very complicated enzyme. Okay, and do you know if at the moment any group discover using virtual screening an interesting compound targeting that region necessary for dimerization? Because I think from all the papers that I read, everybody is focusing on that active side of the enzyme.
Yeah, I think like 95% of the papers are focused on this binding site cavity. I think that I only found one paper which was like directed into this dimerization side, but as far as I remember, it was like in silico studies.
Just in silico studies.
Yeah.
Okay.
So this is like the area which still needs exploration.
Okay, yeah, a lot of exploration. Okay, and regarding this kind of processes, I mean, the processes in which a new disease comes by, unfortunately, let's say, and then somebody realizes, this is the typical drug discovery process workflow, somebody realizes about what the main targets are, somebody solves the first crystal extraction, and then everybody can start to play,
yes,
in double quotes, to play and to discover new compounds, okay? But in this race, okay, people said at that moment, rat race, because everybody was involved. And I mean, it was 18 months ago, and at the moment, there's still no compound approved by FDA.
Yes, that's
okay,
right.
So it's really complicated. But let's have a look in retrospective. How would you think we could, in general, as scientists, accelerate this problem?
Oh, this is very, very complicated.
It's complicated. More money,
more money for sure. But I think that the most important thing is that we really need to join our forces. Let's say it like that. And we need to remember that, yeah, it is kind of competition also between research groups. But anyway, we need to collaborate with each other. And I think that one of the most important things is that we need to realize what other groups are doing, what they can do in their best way, and how we can help each other with our expertise in one area, combining with some other group within some other area, to have like this different point of view for the same problem, and just collaborate with each other. I think that this is like the most crucial thing. And the other thing is that right now we have like plenty of papers and plenty of the results, and it is really difficult to find all these results which are of the special interest for us, because it's like hundreds of papers were published.
And you mean those hundreds of papers, you are talking just about in silico results? Because I think this is the time in all the virtual screening history that there has been this kind of avalanche of virtual screening papers without experimental validation.
Yes.
So I also feel that some journals are kind of rejecting this kind of papers due to the low confidence on the results. But for me, it was also very curious that I think 1 year ago, the first papers were some very big teams, as you told, regarding collaborations, screen experimentally libraries of 1,000 approved drugs. Okay, and I mean outstanding papers. But it was very curious that if you compare those first experimental papers, let's say, there was not totally consensus about the compounds. What do you think about
That's
that?
right. I think that this is also like regarding the methodologies which were used for these studies. But that's the point, that sometimes it was like no consensus between the results, and that's the point when we need to like do a very careful investigation
Right.
of the results, and understanding the results. It's something which is also very crucial here.
Okay.
And maybe, we should have this like big global discussion about these results
Mm-hmm. Yeah.
and to exchange ideas
Mm-hmm.
why it is like that.
That would be really great. I know about some initiatives that started at that moment. There is, for instance, one called COVID Moonshot, which, if I said the name well, it started in the United States, and lots of people joined efforts in order to even do the computations and the experimental validation and so on and so forth. And I think they discovered some molecules, some first line hits.
Yeah.
Okay, so I agree totally with you. The good point, perhaps, about this situation is that most people started to dedicate resources for COVID.
Yes,
okay?
that's right.
So, it should not be very complicated to find collaborators. Another thing is to find efficient communication channels so that everybody can know what the other people are doing, apart from reading the publications, of course.
Yes,
But
exactly.
the problem I see is related with that. There are some other contexts, some other diseases in which, since now COVID has kind of deleted the interest about anything. Now everything is COVID.
Yeah.
There are another diseases in which either some groups are not working anymore, and those diseases are very important. Okay, so what can people do there? For instance, as I understand, you are working now in cardiovascular diseases, right?
Yeah, yes.
Because you are working on an enzyme which is very complicated, at least for me to pronounce.
It's human soluble epoxide hydrolase.
Wow, right.
Yes.
Okay.
Very long. name.
Very long. So for that enzyme is very relevant, but how hard do you think it is to find new collaborators in that context? First, are there many or not? And second, how would you contact them?
Okay, so basically with this enzyme, it is like that it is quite well known for, I don't know, 30 years.
30 years.
It was like the effort to discover new inhibitors toward this enzyme, to inhibit this enzyme. And regarding this, there are research groups which are working on that target.
Mm-hmm.
And we know that from the publication, because there is like really huge amount of publication regarding the possible inhibitors for this enzyme. Also, quite a lot of inhibitors were co-crystallized for this enzyme and were deposited in the protein data bank. Mm-hmm. So we have also information about the possible inhibitors.
Okay, I have to say that Maria wrote a very nice review, which is accepted now.
Yes.
and that review can give you a lot of details. So I will put into the show notes all the references to that review so that you can read about it, and also the link to her research group and all the other COVID papers that are very interesting, so that you can have a read. Yeah.
Great. Yeah. I encourage you to read our review. Because this is something what we did. We reviewed all the deposited structure of this enzyme with co-crystallized inhibitors, because we want to do this computational insight into the structure of this enzyme. And the main point and the main problem with this enzyme and the potential inhibitor is that the inhibitors cannot pass the clinical trials because of their low solubility.
Okay.
And this is like the crucial point in this project. So this is also something what we want to improve. And when we reviewed all these inhibitors co-crystallized with the enzyme, we also found out that in the protein structure there is some there are some additional regions like the space which can be used to expand the inhibitors there. Maybe we could use this additional space to introduce some new groups. So target not only the binding cavity and the vicinity of the catalytic amino acids, but maybe we could expand that space into some different regions.
Right.
And this is the message that we wanted also to share, that please take a look on these different regions, because maybe it can be like a starting point to put some new inhibitors there, or at least modify the existing ones.
Right.
So, yeah.
Right. I mean, that's very interesting. And I also have to say again, nobody pays me for saying this, but the review is very nice. And it's not kind of an usual review in the sense that it also incorporates some data analysis.
Yes, exactly.
Right, about the crystals and about what Maria is explaining right now. And for me, there's something here really kind of shocking, which is, as you said, these kind of inhibitors, they are co-crystallized, people obtain crystals and so on and so forth. But when it came to the clinical trials, they could not pass them because solubility.
Yes,
so
yes.
Does it mean that they didn't know about the solubility problem before they started their studies? Or, I don't know. But now we have started some collaboration on this regard. Now we will check solubility beforehand, right?
Yeah, yeah. I mean, it's not like that they didn't realize the problems with the solubility. Here, the problem is that this binding cavity, the properties of the binding cavities is that it's very hydrophobic. So, yeah, you can imagine that it's really hard to put the groups which are polar, that can increase the solubility and all the stuff related with that. So this is this main cavity, and that's why we spotted that, yeah, maybe we could use this additional space which has some different chemical properties, which can be more polar. So maybe by that we could somehow try to solve the problem.
Okay, that's a good approach. And you report, everything that you say now is reported on your review.
We pointed out these regions which are of particular interest.
Okay.
Yeah.
Very, very interesting. And at the same time, we were talking about a COVID project, now about this enzyme with complicated name problem. But you are also working on another project related with mTOR protein, right?
Toll-like receptors.
Toll-like receptors,
yes,
sorry.
yes.
Yeah, exactly.
Yeah.
Can you give us some briefly summary about this project?
Yeah, so basically this project is dedicated to these toll-like receptors, which are transmembrane receptors. So they are quite complex systems because we have the extracellular part of the receptor, then transmembrane part, and the internal part of the receptor. And they are extremely important in the sense of the immune response because they can recognize different ligands. And there is this whole signal transduction, and it is the initiation of the immune response. So the organism have the information that it should fight because there is some damage, and there is some possibility of some ligand from virus or from bacteria. And the point is that because, as I said before, I am also interested in the behavior of water molecules in a system because they are like very often omitted in the in silico studies. So I want to take a look if they can somehow participate in this ligand recognition, but also in protein-protein interaction, because at the very end of this recognition, first is ligand recognition, and then there is like the whole dimerization of this receptor, and there is also like the recognition of the adaptor protein. So it's like really complicated.
Okay.
And the main question is how water molecules behave in this process. Where are they placed? What is their role in the whole process?
Okay.
So this is like the big question, if the water molecules can act as kind of mediator.
Right. And for this, if I understood it well, you use a tool, a computational tool called Aqueduct. It's a tool developed in your group, right?
Yeah.
Can you tell us a little bit about this?
Yeah, of course. Aqueduct is a tool which was primarily dedicated to track water molecules in biomolecular complexes, and especially in such macromolecules which, for instance, have buried active sites. So it means that because the active site is buried inside the protein core, there is some kind of tunnel network because of the substrate and product transportation, also water molecules transportation. And first of all, it was dedicated to describe those tunnel networks. So we are able to track water molecules in our systems. But basically, we can track any molecules which are present in our systems. So not only water molecules, but also like co-solvent molecules if you are dealing with a mixed solvent molecular dynamics simulation. Also some ions, for instance, if we are investigating the ion channels. By this tracking of molecules, first of all, can describe like the tunnel networks, which is inside the protein. But because we are also using something which we call a local distribution approach, we can also identify like region of the particular interest where the density of the tracked molecules is particularly high. So we can code this region as a hotspots, and they might be important from different point of view, like even drug design point of view. We can also, because we are tracing these molecules and we have very specific pathways of such molecules, we can also calculate some energy profiles. So we can identify some energetical barriers that that molecules need to overcome during the transportation events. We can also use this approach to detect some regions which are of the interest in the sense of protein re-engineering, for example, that we want to, let's say, introduce some new pathway, new tunnel to our system. So like, open the new way to the enzyme. And using our approach, we can also like investigate such regions. So it's like very broad, the possible application of our software.
It sounds awesome. And this tool was totally developed in your group?
Yes,
and,
from the scratch.
From the scratch. And as far as I know, or as far as I understand, and this means nothing because the universe is quite big, as you said, most people are not using or are not considering explicit water molecules in drug discovery.
That's correct.
Right?
That's correct.
So you are one of the few that are considering these water molecules.
Yeah, we also released another review, I think 2 years ago or 1 year ago, when we also described the application of water molecules in general in protein engineering, also like how important water molecules are while studying during the in silico studies, because this is something what people really sometimes omit.
Right, exactly. And then you said this kind of protein reengineering thing sounds really awesome. Could you benefit in that regard about the impact or the promise that tools such as AlphaFold are starting to bring into the biomolecular simulation community? I mean, for the audience, Google, through some subdivision of Google called DeepMind, released some software, some methodology, which is outstanding, called AlphaFold, and which can, they say, it can accurately predict the three-dimensional structure for a protein, starting just from the sequence, okay? There is still some debate, okay, but the clear thing is that in some competitions, AlphaFold was compete against some other state-of-the-art tools, and it outperformed all of them. So it looks like at least much better than current methods, okay? And there you can predict structures and so on and so forth. Would this be beneficial for your engineering approach that you commented before for Aqueduct?
Yeah, I think that for sure, because if I understood your question correctly, if we have this prediction from the AlphaFold, we will have these structures. We can run molecular dynamic simulation to observe the dynamics of this structure. We can use our software to try to describe all these events, this transportation things. We can identify region of the particular interest for this protein. For instance, if there are like proteins which are relevant for some diseases, we can also combine this with our analysis of the dynamics of the structure to gain some insight into the behavior of such proteins.
Good, very interesting, very interesting. So now you are, we had to mention Maria is working on the toll-like receptor.
Yeah.
Okay, she's a PhD student, but if I got it well, she applied to a research grant in Holland. She got it.
Yeah.
So congratulations.
Thank you.
Congratulations. That's a really great achievement. And wow, this is incredible because as we were discussing before, for instance, in Spain, there are no such kind of research grants that can be awarded to PhD students. But in Poland, I mean, this is great. This should be encouraged to other countries, okay? So can you tell us a little bit how was this process in which you applied to this grant?
Yes, sure. So this program that I applied for was called Diamond Grant, and actually it was dedicated for the last year master students.
Okay, master students.
Yeah, master students. So actually the aim was to give these grants to students from different disciplines, because this was not only the life science, but also some other disciplines before the PhD. And it is like, you have your own grant. You are a principal investigator in this grant, so you need to take care of everything in this grant. And the money you can get, you can use for your salary, but also for equipment to purchase some things to the labs, or things you need to buy regarding your project. But of course also for the publications and conferences and some courses. So this is like up to 4 years. And the process was that I need to write the proposal, like the methodology, the whole plan, what is the expected outcome from a grant.
And was it hard for you, this process?
Sorry?
Was it hard for you to start to write? Because this is your first research grant.
Yes.
I guess.
Yeah, it was kind of hard, but on the other hand, it was also fun. Because it was like, okay, so what can be the worst case? You won't get a grant, but this is like your first experience,
Right, that's very
for
important.
writing,
Right.
and to know the path, what you need to do, how to plan everything. And there was this time for writing the proposal, and then you need to wait, of course. There was this 2-stage evaluation, and then there was a result, and you can start working on your research project.
Wow. I mean, but from a point of view, it's outstanding. Application to a research grant during master studies, okay? And as you said, one needs to be kind of optimistic, okay?
Yeah.
As you said, the worst thing that you can have is that you don't get the grant. Nothing happens. I know that sometimes people are afraid to see their names on public lists where they say grant rejected. But this, I mean, this should not be a problem, because if you want to continue in science, on research, this is kind of a hard way, and you need to get used to these kind of situations where you don't get the grant.
Of course.
And not just one, but 3 or 4 or many times, and you need to move forward.
Exactly.
Unless we are millionaires and then we don't need them, right? But this is also, from my point of view, a very good point in order to develop, I think, a successful and long scientific career. I mean, because you need to make a CV if you want to continue forward. But of course, there is the typical complicated question for all PhD students. Do you know now if you want to continue on research, kind of a postdoc, and so on and so forth after your PhD, or this is something that you have not contemplated yet?
Sometimes I think that this is the question I am asking myself every single day. And as for now, I would say that, I think that I will continue with this academic path. So postdoc, for sure. But on the other hand, you never know, and you cannot close any doors
Exactly.
you have. And we will see what happens. But as for now, I would say that, I think that this is like the path I want to follow, to work on some projects and do some research work.
Okay. And so let's suppose if you don't continue in academia, which potential, because these are potentialities, which potential jobs would you look for? I mean, would you prefer to go for industry and continue to work on kind of similar research area, but on industry, or to do like other people that they apply to high school teaching positions that sometimes are even permanent positions supported by state?
So I think that I would try to go to industry and work in similar area, like drug discovery. So maybe some pharma companies or some companies related with the drug design in general. With this high school position, I haven't considered that. But on the other hand, right now I am also doing kind of course in case to have this like opportunity to work in school, because at least in Poland it is like that you need to finish like the specific course in order to have this ability to work as a teacher in school. So this is something what I'm also like doing in the moment. I will finish, I think, in January. This just in case that I think it's important to have like opportunities.
That's right.
To pick what is the best option. What is the best option for you?
Okay.
For instance, with this postdoc, there is like this other part of the story that you need to have some, the project where you can apply, like the postdoc position available. And also there is also this issue of the mobility that you should go to some other place and apply there. And I think that this is also something what we need to have in mind, that sometimes you need to move to other group, or to work in some different project. So it's also like really tricky sometimes to think about all these things you need to take into consideration.
Right. And okay, so that's great. I think you consider a lot of different potential options, kind of continuation in academia, industry, pharma, and then this high school teaching and so on and so forth. But there is a fourth option I can see that you didn't talk about, which is what do you think about the entrepreneurship thing? Kind of let's suppose you publish in Science. I don't know, whatever. I mean, it's not necessary from my point of view to publish in Science to be successful or happy in life, in the research life. Okay, but let's suppose that at the end of your PhD, you kind of discover novel functionalities for your software, Aquadac, and so on, so that you can offer high value to another companies. I mean, you can offer services based on this software. Would you then consider, in some potential case, the creation of a startup, or this is way out of your expectation?
I mean, as for this moment, it's something that I cannot imagine like myself doing that, because it's like totally different from all these things I know. And I know that all this business related stuff are also very like hard and difficult. So I think that my answer is that maybe with some support, like really good support, maybe we could consider something like that. But for sure, I would need to feel more secure in this area to consider something like that.
Okay, so if because some reason you find kind of a team that takes care of all the business, and then you could focus on the research side.
Yes, exactly.
Then perhaps, who knows?
Yeah,
right?
exactly.
Okay. And I mean, I know some PhD students would be now listening to this episode. Would you give them some kind of advice regarding PhD life, or?
Yeah. So my first advice would be put yourself first.
Okay.
And take care of yourself.
Okay.
Because this is something what is really important while doing research.
You mean put yourself first in terms you as person, as people.
Yeah.
Okay. Your life.
Yes,
right?
Your life, exactly. And try to not miss any opportunity for new collaboration, for some scientific internship. Try different things, because like this is I think the time in your life that is the best for you, in terms that you can try many different things, and you don't need to be that afraid about the failure, because we are young scientists, so we are in this point that we don't know everything. I mean, no one knows everything. But the point is that don't be afraid to admit that you don't know something. And I would say that don't be afraid to say like very loud that I don't know and I need some help to understand things. And I think that the most crucial thing is that you can always find some people will help you with your problems. And so just don't be afraid to ask for help, and try to develop some collaborations and networking is like really, really important, because you never know when it will be important.
Right. And what do you do in order to grow your network?
Okay, so first of all, I would say that conferences and courses, because this is like a very good place to start.
Even nowadays, online courses or things, do you think they are helpful, or do you mean in the past or right now, because they are starting to be in physical person again?
I mean, I prefer in person, obviously, because I think it's easier to have this conversation in front of your poster, or just go around with people and talk. With online, I think it's a little bit more difficult, but it's not impossible, because there are like these rooms in Zoom or some other possibilities to create new connections, let's say like that. So courses and conferences, I would say, but also this scientific Twitter is also something what is really nice. And I think that actually Twitter or LinkedIn was one of the source how we could start our collaboration with our partners from Switzerland, also on COVID paper, one of the COVID paper.
Oh, really?
Yeah. So with PhD student from Switzerland, we were in touch, and we said that okay, maybe it would be nice someday to collaborate.
Everything started on Twitter.
Yeah, or LinkedIn. One of these two websites.
Okay.
And then and we published a paper together.
Wow, that's great success.
Yeah. So it started from such collaboration, like like following each other on one of such social media.
Wow.
So social media right now it's like really, really important.
Right.
And also like networking in the sense of your like boss, for example, know some people, and those people they know other people, and this is how it starts.
I mean, I think this is good advice. Please, I would say, if you can take just one single advice from Maria, I would take that one from networking. I mean, this is something very personal, but I think this is something very, very relevant. I mean, this is networking because, for instance, by the way, I have to say, I started some collaboration. I started the collaboration online first with some people from the same city that Maria is. Then they invited me for a talk. And then on this talk and meeting, I met the PhD advisor from Maria.
Yeah.
And then we started some collaboration. And now Maria came from Poland and is here in Murcia. So, I mean, that's right. Networking can give you lots of very good things and give you a lot of opportunities for your career, for the next steps, for everything. I mean,
exactly.
Incredible. Wow. And one question, how could we say is one day of your research life? What do you do? You work each day on a single project, or you juggle with very, very different projects? How do you do?
I think that, the second option. So different projects. So I would say what is like the urgent need depending on the project, because also sometimes I don't know, you're running molecular dynamic simulations and you need to wait 4 days to finish the calculation, because I don't know, you are running 100 nanosecond simulation or something like that. So you are not just sitting and staring at the computer screen. You can do some analysis of the results for this project or for some other project. Then, of course, publications are really important. So you also need to take care of writing. Sometimes it's just writing.
Right.
Sometimes you try try some new method. Sometimes you need to check if some new functionalities which were added to your software are working correctly. So you do all these exercises if everything is working correctly. So I would say that I don't have like the same procedure,
Okay,
the same
you don't have
schedule
procedure,
for every single day. It's really up to the needs.
To the needs, right?
Yeah, concerning the projects.
Okay, do you somehow plan your week or month or I don't know year in the most extreme way in advance, or you just try to be more agile and depend on the day?
No, I'm trying to plan in advance. We have like this, let's say, schedule that, for instance, till the end of the month, such analysis should be done. So I try to, have a tracking of the progress and try to stick within the deadlines. Sometimes it's really hard because you don't know if everything will finish correctly, or I don't know, you have the results but you realize that there was some mistake in your file or something like that. So you need to be like flexible enough to change something in your schedule. But yeah, mostly I am trying to have some schedule and have some, I don't know how to call it, like milestones.
Right. Okay, that's very, I think this is something very personal. It depends on the personality on each one. Okay, but I would also advise to PhD students also, you can have some projects, but you don't have typically 100 projects, which you will have when you reach the postdoc stage.
Yes.
So at the moment, I would recommend anyway to have this kind of milestone, this programming, in order to be efficient.
Yeah, of course, you also need to take care of some other responsibilities, because for instance,
exactly.
Because I have some teaching obligatories as well at the university, or some classes or courses I need to take. So of course you also need to put this into your schedule.
Right.
And yeah, this is also something what you need to take into consideration, that there are some additional activities. It's not like only research and sitting in the lab and doing things.
Many things going on, I thought. And regarding the scientific life, what is the thing you like the less?
Administration stuff. Yes.
You had to do also administration.
Yeah.
Right,
yeah. Some part of the administration. Yeah. So this is my least favorite thing to do. Yeah, and what else? I don't know. I think it depends on the project. But sometimes, waiting for the results, it's also something not very nice. Or when you have this situation when your calculation fails and you need to think what is going on, what is wrong, and sometimes you have no idea and you're struggling, I don't know, 1 week, 2 weeks, or like just thinking about what can be wrong.
Exactly what happened on that. Yeah, that's a very common problem. That's right. So thanks, Maria. Thanks a lot for this very interesting interview. Also, I just wanted to ask you if you want to leave some question for the next interviewee, which at the moment you don't know.
Yeah.
Neither do I. Okay. But what we do is that the last people to interview will give some question for the next one. So if you want to leave one of them, you are welcome.
Okay. So maybe my question would be, what do you think will be the next big discovery in science? From which discipline? I think that would be my question.
Okay, very interesting question that can give even for a series of podcasts. Very nice. So thanks, Maria, again for accepting this invitation.
Thank you.
Wish you the best in your career. Thanks a lot, and bye bye.
Thank you. Thank you for having me here. Bye bye.
Gracias por estar ahí y por escuchar este podcast. Os recuerdo que en la nota del episodio tenéis los detalles sobre muchas de las cosas que hemos hablado hoy y también un formulario donde si quieres puedes opinar sobre el podcast, para bien o para mal, como quieras, estás en todo tu derecho, y también sugerir si quieres un próximo entrevistado o tema que está relacionado con la investigación, claro, pues tu opinión me parece muy importante, tanto a mí como a toda la audiencia de este podcast que va creciendo y que va contando muchas cosas interesantes. También comentar que si te interesa alguna de las técnicas que hemos mencionado hoy de manera muy breve en el podcast, me puedes contactar directamente y te puedo dar más detalles. Y por último, si te ha gustado, te agradecería muchísimo que lo recomendases a quien veas que le puede interesar y difundirlo por las redes sociales o donde sea. Y nada, y si estás en Apple Podcast, pues ponernos ahí 5 estrellas o 4 como quieras. Siempre viene bien. Muchas gracias. Hasta luego.